Hi everyone and welcome to a new video. Today we're going to talk about the primary memory, specifically RAM and cache. First, before we start, let's talk about the difference between the primary memory and secondary memory. So primary memory, as we said, they are RAM and cache, and secondary memory, we're talking about the hard drive of the computer. So the first difference between a primary memory and a secondary memory is that primary memory is volatile while secondary memory is non-volatile. That means in order for primary memory to keep the information, to keep the data, it has to have the power. And as soon as it doesn't have the power anymore, then your computer you will lose all of the data that you stored on your primary memory. On the other hand, anything that you store in your secondary memory is going to be non-volatile. That means even if you turn off your computer, you will still have access to all of your information. That's why they always say, for example, if you write a document in your Microsoft Word, or if you're making a PowerPoint or anything like that, the best practice is to constantly, whenever you're making changes every once in a while, to save your data. That means you're sending it from volatile to a non-volatile memory, and that way you won't lose your information if you lose the power to your computer. So another difference between a primary memory and a secondary memory is that primary memory is way faster than secondary memory. And another difference is primary memory have the lower capacity and secondary memory have the higher capacity. For example, a primary memory like RAM might have 4 gigabyte to 16 gigabyte storage capacity, but secondary memory can go up to 1 to 2 terabytes of information that you can store. So now in the primary, we are going back to the primary memory again. This is a picture of a RAM. As you can see, RAM is a stick, and there are pins at the bottom, and there is a notch on the bottom of the RAM. And for the cache, I put a picture of a CPU. The reason for that is in the recent systems, cache is normally inside of your CPU, so it is not external from that. All three levels are normally inside of your CPU. That's why I put a picture of a CPU for the cache. And then another thing that we have to clear at the beginning is that RAM and ROM are two different things. It's true that their name are very similar, but they're two different things. RAM is a stand for random access memory, and ROM is a stand for read-only memory. So random access memory is the stick that goes on your motherboard, but ROM can be anything, but mostly it is like a chip, and these chip can for example, there is one form of this chip which is EEPROM, electrically erasable programmable ROM, and it is used as the BIOS for on your computer, a BIOS chips on your computer, and it does a totally different work from your RAM, because BIOS chip, it just helps your computer to boot up, but the RAM is the one which have all the information, all the data, or the software that you're currently use loaded on it, and it has a direct access to your CPU, but ROM doesn't have a direct access to your CPU. That means it needs to load its information on your RAM, and then RAM will feed the information, the data, to the CPU. So another difference between RAM and ROM is that ROM is non-volatile, so it will keep the information even if it is shut down, and RAM is, as we talked about, is volatile. We're going to talk about ROM more when we're talking about the motherboard of the computer. So now let's see how does primary memory works. So whenever you want to download or install a, a software, you will do that. You will install it on your hard drive. You will download and install in your hard drive. Whenever you want to use that software, your computer will load it on your RAM, and then RAM will feed it to your CPU. The reason for that is hard drive is normally your mechanical part of your computer, so it is way slower than your RAM. If your CPU wants to use the hard drive, the performance of it will become very low, and it doesn't matter how good your CPU is, because it doesn't get the data as fast as it should get. So that's why it will become very slower. Most of the time your CPU will do nothing, will just sit there and do nothing. So that's why your performance will go lower even if you have the best CPU in your computer. So RAM is way faster than your hard drive. And it can feed the information or the data faster to your CPU, so that way the performance will go higher. And on the other hand, there is another primary memory, which is called cache memory, and it has 3 levels: level 1, level 2, and level 3. And level 1 is the fastest memory that exists in your computer, and it has the same clock cycle as your CPU, so it is super fast. And whenever your CPU wants to get some data, first it will go to the level 1 of the cache, and if it finds the information, it will come and process it. Then if it couldn't find it in the level 1, it will go to the level 2, which is a little bit slower than level 1. If it couldn't find the information, it will go to the level 3. If it couldn't find the information, then it will go and take the information from RAM. So that means that the level 1 information are the information that the level 1 cache has the information or data that your computer uses the most frequently. And then after that, if the information or data is not cached by the first level of cache, it will be stored on the second level and on the third level, and finally on your RAM. So yeah, this is how the process works. And there is another thing about the RAM. So for example, you have a software which requires 6 gigabyte of RAM, but you happen to have 4 gigabyte of RAM. What happens is that 4 gigabyte of the information or any amount can be loaded on your RAM, and then after that the data will be feed to your CPU, but then have some extra part of your software is still in your hard drive. So what happens is that your RAM will go back and forth from hard drive to get those data of the software, and then from there it will feed it to your CPU. So as you can see, if the capacity of your RAM is low, for example, if it is 4 gigabyte and you need more than that, the software needs more than that, the performance of your computer will become so low because it needs to go from the hard drive and get it from the hard drive, which have a lower speed than RAM. So that's why the easiest way to fix that problem is just to put another RAM, install another RAM in your computer, or you can change your RAM to a higher capacity RAM, and that way this problem will be solved, because all the software can be loaded on RAM at the same time and it can be fed to your CPU. So now let's talk about the RAM specification. When you want to buy a RAM, what you should consider. So first thing is that you have to consider is your RAM type. RAM type SRAM is normally the cache RAM, and DRAM is the most common type of RAM that is used in the computers, and it is from DDR to DDR4. Most of the computers today use DDR3, but some higher performance ones use DDR4 as well. So it is very important to choose the right type of RAM based on your motherboard type, because if they have those notches at the bottom that I will show you again later. Those notches have to have a place on your motherboard, and you want to make sure that you get the right one so it will fit. And then there is RAM speed, which it is important as well, but it doesn't make that much difference from the DDR3, which is the speed is from 800 megahertz to 2133 megahertz in DDR4. It is important RAM speed, but it is not as important as RAM storage. So RAM storage have to be from 4 to it doesn't have to be, but the most common one are from 4 to 16 gigabyte. For the people who have the very basic use of the computer, for example surfing the web, or watching Netflix, or using Microsoft Office, normally 4 gigabyte is enough. If you're on budget, you can just use the 4 gigabyte one. The best option is to have the 8 gigabyte one, and if you're playing very high definition video games or things that needs your computer to perform very good, then you will go for 16 gigabyte RAM storage. So this is what we talked about. RAM on motherboard, these are the slots that the motherboards, the memory sticks will go in. And as you can see, these are two different type of RAM, DDR2 and DDR3, and these are the notches at the bottom. These are the pins. These pins will go inside of your memory sticks, inside of your memory slots on your motherboard. So you want to make sure that these notches have the right place on your motherboard. So if, for example, your motherboard is compatible with DDR2, if you buy a DDR3, you won't be able to put it inside of the slots because of this notch, because this notch is in a different place. So that's why you always want to make sure you get the right type of memory stick for your motherboard. And that's it. Thank you very much for watching, and see you in the next video. Bye.